Hello everyone, it's your humble DBA again. Today we're migrating an AWS Oracle 11G RDS environment to Azure Platform MySQL 5.7 environment using a combination of PLSQL, Azure Data Factory, and MySQL programming language. Safe harbor, this is just a fun exercise. There are many ways to integrate data, and should you have the budget, it's best to purchase the proper tools of the trade. This is just meant to show a deeper understanding of the underlying mechanisms of Oracle PLSQL and Azure Data Factory. Our source configuration is generic as possible. We have an AWS Oracle 11G environment with source table with data and an audit table that captures the changes from the source table using insert, update, delete trigger. The DDL we're using is also as generic as possible. There are no keys, no referential integrity, requires no disabling of indices or ordering of tables. Our audit table contains a few additional columns: operation, which describes the source row DML, i.e. inserted, updated, or deleted, and row state, which describes the state of the row is in from context of the data migration process. There is a limitation in Azure Data Factory. It is currently not possible for ADF to call Oracle PLSQL stored procedures. So we have to abstract that data movement call using an autonomous function. This is because the entry point for this, the lookup task, requires a row type return value. So this is what the functions look like. We call our PRAGMA autonomous transaction, which basically means in one session we have two unique transactions, and thus it's possible to commit. This is our insert, update, delete trigger, fairly generic. If the incoming row is marked as inserted, it inserts a row into our audit table marked I. If the incoming row is marked updated, then it also inserts a row into our audit table marked U, and then the alternative is it's deleted. And then our target database DDL is very similar to the source DDL as their sibling databases. And we'll also have to flip the log bin trust functions creator flag to 1. That's because for the binary logging enabled in default by Azure Platform, we need to force it to trust us as the creators to deploy the function call. Here is the upsert function on our MySQL side. So we iterate through the audit table, ordering by created timestamp, so everything's in the proper order, i.e. the delete comes after the insert. We have, if the operation is marked as an I, we insert it. If the operation is marked as a U, we update it, and if it's marked as a D, we delete it. So there's a weakness in here, is that in the source environment, if the update is not on the primary key, which here we assume it is, then we'll have a inconsistency between the source and the target data sets. So this is why this is not best practice. So on Azure Data Factory, we're creating two different pipelines. One's the initial load. The second one is the incremental load. Basically, they do it as they describe. The initial load is meant to execute one at a time, front-end load all the rows from the source environment into the target environment. We have 4 different states. We can go through them right now if you like. Copy all the rows from the source table into the source audit table as an insert operation, and then mark all of these rows for upload. Upload all of these rows from the AWS Oracle source audit environment to the Azure Platform MySQL target environment. Mark all the AWS source audit rows that have been uploaded to upload complete, so we don't have to do this operation twice, or we don't accidentally duplicate data. We migrate all the rows in the Azure MySQL target audit table to the Azure MySQL target the target table using that upsert command. Here's a little graphic describing what we're doing. So we have our source environment with rows in it. We create an audit table using PLSQL. Using Azure Data Factory, we move this audit table into the Azure platform, and then using our MySQL programming language, then we move it to the target table. Let's begin. Hi guys, so the first step is to create our Oracle 11G environment on the AWS platform. So we'll migrate to RDS. Create database. Want to make this as cheap as possible, so we will configure it to be, there we go. Free tier. We will call this environment Oracle source. We will put in our generic credentials. We can disable auto scaling. Default VPC, nothing fancy there. We will also configure it for public access. Unfortunately, we'll have to be reaching out to this to the public internet because the Azure Data Factory will need to remote connect in. Standard VPC security group. We're not doing anything fancy here, so we can just skip on through this and create database. All right, see you guys shortly. All right, everyone, database is built. So now we're going to connect in, configure our TNS name so we can remote in and execute our script. So first thing to do is set up our TNS names. Get our endpoint, as that is our host name. And then we're going to TNS ping it. Okay, and we're going to connect in using our admin credentials and our given password that we set when we were configuring the database. Now we're in. So now we can execute a script. Before I execute scripts, I'd just like to read over them. So provided this user was there, it is not. It would drop this user and all of its related objects. So the first thing I do is I create a data store object that'll hold all of our tables and triggers and functions. And then I set this user to have unlimited access to quota on tablespace users. And I create my source table. And then I create my audit table. And then the functions that we listed in our PowerPoint presentation and our trigger. And then we're going to insert some data into our source table. And then we will watch it flow into our target table. Let us grab the text. There we go. Now we're just going to query the source table. And query our audit table, which should have, perfect. So in our audit table, we've got all of the rows from our source table, plus some additional values. We have a created timestamp. That's the date that the row was landed into this audit table. We have our operation, which is an insert. And then we have our row state, which is new. All right, see you in the next step. All right, guys. So the next step is to create our target environment, MySQL 5.7 on the Azure platform. We will create it. Humble DBA. Place it in Canada. Make it as cheap as possible. We don't need to incur any unnecessary costs. Let's call this one Humble DBA. Okay, I'll pause the video and come back when the build is done. All right, guys, so the MySQL deployment is done. Let's go to the resource and make our configuration changes. First thing is we allow ADF to communicate with this resource. We'll then add our client IP address so we can communicate from our local PC directly to this resource. And we will disable SSL because I'm too lazy to set up the certs. Then we'll go to our server parameters and set our log bin trust such that we can deploy the function. And then we will deploy our DDL. First thing we do is grab the hostname. Then we go to AUTHID, which is a free MySQL tool that I like to use. Punch in the required parameters to connect. Okay, now I'm going to grab our script. So again, I'll walk through it just so we know what we're deploying. So I'm going to be creating a target database. I'm going to be creating our target table to load data into, and I'll be creating our audit table. It's named identical to the source environment. Our upsert data function iterates through, using a cursor, the audit table, and filters on whether or not that row is inserted. If so, it inserts the test target. If it was updated, it updates the test target table, matching the primary key. I've already pointed out that this is a bit of a weakness in the solution. And or a delete, in which case it'll delete from the target table where it matches the primary key. So first thing we'll do is we'll create the target database. Database exists, so I've already created this. I will deploy our tables. And then I will deploy the MySQL function. Okay, jump back to this. And we are ready to proceed to creation of the data factory. So we'll navigate to our dashboard. Navigate the data factories. Add. Put it in Canada Central. Humble DBA, Oracle to MySQL. Don't plan on using Git, so we'll turn that off. Networking, private endpoint. I'd like to add tags, of course. In this case, there's no need, as this is just kind of a showcase. And then we will deploy. I'll pause the video and come back when it's done. All right, guys, data factory is deployed. Let's navigate to the resource. Author and monitor. First thing I like to do is configure the data sets. So we will do that now. Configure the source environment, which is Oracle. Need to create a new link service. We'll call this one Oracle Source Link Service. The host is our AWS endpoint, which we've used to configure at TNS, among other things. Port is default 1521. Oracle SID is Oracle. Username is admin. Our password is our generic password, which we use. Test configuration, test connection. Good to go. Now we'll create our MySQL environment. Create a new link service. Let's call this one MySQL target link service. Disable SSL, don't need that. Test connectivity, failed. Why did it fail? Oh, because we gave it the wrong username. So in this case, it is, we can grab it from here. There we go. Create. Good stuff. You can clean up these to make sure they're more appropriately named. This will be MySQL target dataset. This will be Oracle source dataset. We can do a preview data. Oh, I'm going to configure the table name, which is datastore, and it's the audit table we wish to move. We can do a preview data. Make sure we have valid data. Okay. Next, we will create our pipelines. All right, next steps are to create the initial pipeline. I like to mock it up so I can understand what I'm doing as I'm doing it. So the first step would be to mark the rows for initial load. Once again, because ADF does not allow us to directly invoke an Oracle stored procedure call, we have to hide it under a function, which then lookup, because lookup requires a row type return value. That's how we're doing it. It's a little bit fancy, definitely not standard. This is marking all the rows in the audit table with a U that have not yet been uploaded. And we'll copy the data, move it from our AWS Oracle environment to our Azure MySQL environment. Oracle. Filter from our audit table. Where the row state has been marked as ready to uplift. Target will be our MySQL environment. We'll truncate the audit table to prevent duplication of data. And then we'll do our schema mapping. Next thing we'll do is mark the table that we've just uploaded as completed. I like to make my function calls as closely to the natural language as the descriptors for the tasks. Makes it a little easier to debug later. And finally, we will merge with the target dataset from the staging environment. And we'll pass a 1 because we want it to truncate the target environment so it's a clean load. Now I'll beautify this a little bit so it's easier to look at. Trace it through as it executes. And then go. There we go. Now we can jump to our target environment and query the table. It should look exactly like the source environment. Perfect. Excellent. All right, let's do our incremental load pipeline. Oh, first we'll clean up the language here. And then we will create a new pipeline. Call this incremental load. Mock it up first, of course. Beautify it a little bit. Fill in the details, source environment. Depending on your strength with SQL, you may or may not like to run this code in your CLI. Source environment to uplift is Oracle. Once again, we'll filter the audit table and those rows have been marked as upload. Sync it with MySQL. Truncate the target audit table so we don't have any duplication. Good stuff. Mark the rows we've just uploaded as completed. And then finally merge from the audit staging tables into the final target. Pass it to 0 because we don't want it to truncate the table before it starts. All right, let's run this. It shouldn't change anything in the underlying, as the underlying data set hasn't changed. So this is more of a syntax pass. Good stuff. Jump to our target environment. Query it shouldn't have changed. Everything is good. Now let's change some of the underlying data and then retest. So I'm going to grab some pre-compiled scripts I've had here. So we're going to do an update and another insert. Commit this. So this is what the source table looks like now. We're going to run our incremental load pipeline. Query the target table. Compare it with the source. It's looking good, guys. All right, let's delete a row in our underlying data set and then rerun. And there you are, the poor man's integration tool set. If you have no budget and you need to move an Oracle environment from AWS to MySQL on Azure, you now have a solution. Thanks, guys. Appreciate your patience and enjoy your Halloween.